All right, now that we have seen what Euler's formula is, why don't we apply Euler's formula? All right, to make a polyhedron-shaped game, to make, to make polyhedron-shaped game pieces using a 3D printer, Juanita enters the number of faces, edges, and vertices into a program. If she wants a game piece with 20 faces and 30 edges, how many vertices does the piece have? So let's apply Euler's formula to answer this question. So Euler's formula is the number of faces plus the number of vertices of a polyhedron will be equal to the number of edges plus 2. So we are told that we have 20 faces, so I'm going to substitute 20 in for F, and 30 edges. I'm going to substitute in a 30 for E. And the question is how many vertices? So we don't know the vertices, so I'm going to leave the plus V. I'm just going to carry down that plus 2. And we can take this little formula and solve for V. Why don't we go ahead and combine the 30 and the 2. So we have 20 plus V equals 32. And then just subtract 20 from both sides, and we can see that Juanita will need 32 minus 20, 12 vertices. All right, so now that we kind of see how this works, let's just try a couple more examples. Part A, a polyhedron has 12 faces and 30 edges. How many vertices does it have? Well, Euler's formula says the number of faces plus the number of vertices is equal to the number of edges plus 2. All right, they told us 12 faces plus, and then how many vertices? So now I know, just leave the V in there, equals, we've got 30 edges, so I'm going to substitute 30 in for E plus 2. All right, well, that's a 32 over there. Didn't we just have a 32? I'm going to continue my work. 12 plus V equals 32. Let's go ahead and subtract 12 from both sides. So the number of vertices would be 20 vertices. All right, part B, can a polyhedron have 4 faces, 5 vertices, and 8 edges? Explain. Well, we can test this out in Euler's formula. We know that in a polyhedron, the number of faces plus the number of vertices will equal the number of edges plus 2. So can we have 4 faces? So I'm going to substitute in a 4 and 5 vertices and 8 edges. So let's check to see. 4 plus 5 is 9. 8 plus 2 is 10. For this to work out, these two need to be equal to each other. So because 9 does not equal 10, it does not satisfy Euler's formula. So can a polyhedron have those number of faces, vertices, and edges? No. How do we know? It does not satisfy Euler's formula.